Hi everyone, my name is Ote. I'm one of the creators of Atlas, and in this video I want to talk to you about how we prevent conflicts between developers working on the same project. If you ever use GitHub, you probably know this screen. If you are working on a branch and you are suggesting some change in a pull request, but you change some file that someone else on your team has changed in the time since you made your branch, Git will detect this conflict. It will try to resolve some things automatically, but in many cases it's not possible, forcing you to manually resolve the conflict. This is a really great property of a source control management systems like Git. Now, unfortunately, with schema migrations, this thing doesn't really work, and I want to show you why. When a developer makes a change to the database schema, they often create a new file, a new migration file. If two developers try to change the same table, for example, the pets table, in a conflicting way, they will each create a separate file. For example, in this slide, you can see Adam and Sarah. Adam is working on feature B and Sarah is working on feature A. They each create a new migration file in a different time, so they each got a different file name for their migration file, and they will both be able to merge their change without conflict. Now, for Git, this is fine, but their database will probably not be so happy if both of them try to add the same column in the same name or make a change that is somehow logically conflicting, will not work on the database. This conflict will only be discovered when the changes are about to be applied to a database. With Atlas, we want to prevent Adam and Sarah from ever merging two conflicting migrations to the main branch. We don't ever want our database to need to deal with this conflicting orders. We don't ever want the deployment to break because of this conflict that wasn't detected by Git. So we really wanted to find a way to detect these changes, these conflicting changes with Atlas during the development flow. Here's what we did. The order of the files in your migration directory matters a lot, which is why Atlas maintains an additional file called atlas.sum that helps Atlas maintain the integrity of the project, making sure that no file in the past was changed and that the order of the files did not change at all. The way this integrity is maintained is by using a reverse one branch Merkle tree, in which the checksum for the first file is computed and the checksum for the second file is computed using the checksum of the previous file, resulting in a data structure where if something in history changes, the total checksum changes as well. This computation is done for you by Atlas and is validated with every interaction you have in Atlas. If you try to add a new migration, if you try to apply a new migration and your checksum is off, Atlas will complain and you will have to fix it using the tool. Fortunately enough, this can also be verified during continuous integration, preventing cases where you push to your main branch changes that break the project integrity. In the case of Adam and Sarah, this file will cause a Git conflict on the header file, preventing one of them from pushing the conflicting change into the main branch. Let's see how. Okay, let's simulate this workflow, this process where two developers try to make different changes to the same migration directory working in parallel. So first off, let's pretend we're Adam, right? We're on Adam's branch. We want to plan a new migration, right? To add the pets table. Create table pets. ID, int, primary key, name, text. Okay. Cool. This is Adam's change. You can see that the atlas.sum file is changed. Right, here's our new header and our new line and our new migration file. Let's add bets table. We'll push it, create a new pull request. This is Adam's change. Cool. Now, this didn't land yet, right? Nobody reviewed this yet. This wasn't merged. Let's go back to the master branch. Start fresh, right? And now let's pretend we're Sarah. Okay, now Sarah wants to make a very similar change, right? Alter, or not alter, create table pets and ID primary key, and let's say a nickname or changes a bit different. Okay, so we can see the same thing. The sum file changed and a new file was created with a different name this time. Okay. Add pets table. And we're going to push this. Going back to GitHub, we are now going to create the pull request for Sarah. And as you can see, we now have two conflicting changes that only one of them can actually be merged, right? We can't have two people create the pets table. So let's start by landing Sarah's changes, right? Cool. Well done, Sarah. Your changes are in master. Now, what do you think will happen to Adam's pull request? Adam still has this open change that he wants to make to the repository. But like we discussed, if both changes land, the results can be very problematic. So let's see what happened to Adam's pull request. You see GitHub is checking and indeed discovered that the sum file conflicts. Let's see where the conflict is. Indeed, we have a conflict here on the sum file header. So this example shows how Atlas can help you detect and prevent cases where two conflicting migrations are merged to your main repository. If you don't have something like this, you may very well end up in a situation where you try to run conflicting changes to your production database, causing deployments to fail, or worse, migrations may be skipped. If you already ran a later migration and only then a new older migration file with a lower version is merged to master, it may never run. So the database backs your application. You really want to make sure that things are in order. I hope you enjoyed this video. If you want to learn more about Atlas, please visit our website at atlasgo.io. Please subscribe to our YouTube channel and give this video a +1. Thanks a lot. See you in the next video.